So hello, good evening, and welcome to a new food4Rhino webinar. We have today with us Michael Brunner, Matias Penrroz, and Miro, all of them working for Cadwork. They are architects or engineers specialized in wood construction, and they are going to present this new connection, this new live link between Rhino, Grasshopper, and Cadwork. Cadwork is the standard BIM software for timber construction, developed in Switzerland since many years. They will of course now start with a little presentation about it, and we are so happy to see more and more live connections like this, because it's great, I guess, for all Cadwork users to be able to use now Grasshopper as its algorithmic editor, and vice versa, to Rhino and Grasshopper users to be able to have a direct connection to a wood construction software. So thanks, Michael, Matias, and Miro for being here and for having organized this webinar. It will last around 45 minutes. The last 15 minutes will be for questions to the viewers. Please use the chat for any questions you might have, and then at the very end of the webinar I will pass these questions to the presenters, to the speakers. And also, in case you miss any part of the webinar, this is being recorded automatically and it will be later available on this same link. By the way, if you want to learn more about the biographies of Michael, Matias, and Miro, you can check the details of the webinar on YouTube. There, if you click on details, you will see all their bios. So thank you again for being here. And now, please, you can start with your presentation.
So, yeah, also hi and welcome to the webinar about Rhino-Inside Cadwork from my side. My name is Michael and I work at Cadwork Switzerland. I'm here today with Miro and Matias. They are from the University in Biel and they work at the Institute for Digital Economy in the construction and wood industry. In the first part of this webinar, I will introduce you to the software Cadwork and of course to Rhino-Inside Cadwork. In the second part of the webinar, Miro and Matias will show you the use and the potential of Rhino-Inside Cadwork on a project they did at the university. Yeah, the history of Cadwork starts in Lausanne, Switzerland, at the EPFL in 1980 on a research project. And then from there, the headquarters from Cadwork was founded in 1988, and it's still based in Basel. Since then, there have been more than 20 offices all over the world established. Cadwork offers different software modules, especially for timber construction, like machine processing, point cloud, BIM tools, and so on. And from Cadwork, there's also civil engineering tools available, like Cadwork 2DR or LexoCAD. In Cadwork 3D, we have a strong focus on timber construction and processing analysis for CNC machine. It means all like manufacturing specific requirements, as well as installations like MEP and so on, must be taken into account during 3D modeling. It means like all production relevant requirements must be taken into account due to the high level of prefabrication in the wooden construction. As you can see here on these two images, it's just some samples of detailed constructions where already in the model all cutouts, drilling, paths where the insulation is passed through has to be considered. And like from the model we have here, the data is in further steps transferred to a CNC machine via several export options from Cadwork. Yeah, in Cadwork, you create, or you have to create, a correct as-built construction model. Yeah, in addition to the geometric modeling, also like the properties for material and further important information are added to them elements. Yes, in Cadwork, it's a lot of focusing for manufacturing, processing, and therefore Cadwork offers specific element types for that, which are used for machine processing. These includes, for example, the drilling, which we see on the left side. This is like an axis with a diameter. You can see it on the picture next to it that we have this also available for the Grasshopper plugin. Here you pass like a start and an end point of this axis, and then define a diameter, which will then in further steps generate a drilling. On the right side, we have the connector axis, which is based on the drilling, but is a more complex element. This element allows us to create like drilling, specific drilling in each sector. If we have like multi-layer elements, then we can specify for each layer, for example, a different processing or different drilling. This is as well available in the Grasshopper plugin by passing a name for the standard connector and also passing a start and an end point, as well some attributes. Then in the past, for wood construction, it was not very efficient to use like wood-wood connections, like we see here on the picture on the left corner with this dovetail. But with the use of CNC machines, the wood-wood connections experienced a rebirth and are very often used. In Cadwork, there we offer a parameterized solution for these joints called end types. And with the Grasshopper plugin, to set these end types directly from your Grasshopper script. And this works just by passing the name of your end type. Yeah, and then I talked already about this processing analysis. That means like that cutouts and machine-specific elements like this bolt or connector axis, as well as the end type, is then detected in this analysis, and or there the processes, the required processes are detected, which are then will be in further steps transferred to the machine data. Here you see on this picture on the right top corner, like at the start and at the end of this beam, we see the dovetail. This is coming from the end type, and then this blue cylinders are the drillings. Like from the process in wood construction, we have like the CAD, the CAM, and then in the end, for example, a CNC machine for the production. And like in Cadwork, we define the milling process, and then the CAM software creates the strategy to produce them. And then on the CNC machine, these processes are executed. Here is a small animation of how something could look in a CAM system. Here in Cadwork, like the process is defined for all the cuts or for the nailing paths, and then in the CAM system, the strategy is created. Cadwork offers as well a lot of interfaces for or imports and exports for different file formats. Of course, the one we talk today about, Rhino.Inside Cadwork, but there's also like native Rhino import and export. Then we have also like a native Revit import, and as you can see, some more file formats. Then we've also like a strong focus on BIM topic, and we also offer 2 APIs, one for Python and one for C++, which offers a lot. Like from all these file formats we can import, there we have there Cadwork offers a huge advantage with this geometric analysis. That means we can import them geometries and then analyze them and evaluate like the process for the machining. Of course, you see like all is in double quotes. That means the quality of the geometry has to be good. Yeah, with Rhino.Inside Cadwork, it is possible to connect Rhino and Cadwork, and that means we can combine the strength of Rhino in terms of parametrics and also of complex geometries with the strengths of Cadwork. And this gives us, or together with this combination, we get completely new possibilities in modeling. The plugin Rhino.Inside Cadwork is available from food4Rhino and as well from the package manager. We also have a documentation for Rhino.Inside Cadwork, which can be found under docs.cadwork.com, and there like the input and output parameters and some examples are available. In the plugin, we have some components to manipulate or create attributes, filter elements by attributes, select Cadwork elements and connect them with Rhino Grasshopper. Or on the other side, we are also able to create Cadwork specific elements directly from Grasshopper. This could be a beam, a panel, or architectural elements. Yeah, now I will show a short demonstration of the usage of the plugin before I then hand over to Miro. I already started here or run here Cadwork and Rhino on my machine. As you see here on the top right, where I'm currently at, this is Cadwork. And on the left side, we have Grasshopper and Rhino. So just to show you how you start Rhino.Inside, we have here under Tools, we have a button Rhino.Inside Cadwork, and from here, like the connection of these two processes is started. Now, in Grasshopper, we see here like the components which I showed before. I said we have some 4 attributes: element selection, element creation, architectural elements creation. Now here in my case, which is prepared, I have here the components for selecting elements, and from here via the context menu with a right click on this component, I can click on select Cadwork elements, or I would also be able to import something from a 3D or from a 3DC file. And that means like that I can connect catalog elements, some steel connectors, and then load them and work with them in Grasshopper. But for now, I will connect with Cadwork elements, and when I click here on this button, then I get here like a prompt to select elements, and therefore I select here like these beams, column and beams, and then with a right click, I submit this selection. And now, as you can see, I have here some elements connected. These are now 7 B-reps, and then I can do more stuff with them, like filtering by attribute. Here I pass like the attribute name from Cadwork, for example, the name, and then filter for all elements with the name beam. Then here I'm just doing some like simple stuff in moving the elements, which I have filtered. And then here to the more interesting part, like I have here a single element, which you see here in the Rhino software, like this beam. If I deconstruct this B-rep and get all the faces, edges, and vertices, I can then bring them back to Cadwork. Example here with this component for creating lines. Now we see like the outer line of this element, or or like the surface, or also the nodes, which then are directly generated in Cadwork. Then we are also able to create elements like beams, which I have here with this component. Here I also just moved these elements in Z direction, and then with this component we can create these geometries in Cadwork. And as you see, as input parameters, we have a geometry for the B-reps, then we have an input for axis, and that's a very important thing for Cadwork, like this axis system. Like each element in Cadwork has a local axis system, which is important for machining and general modeling processes. We see here like this right-hand coordinate system with X, Y, and Z vector. And these vectors, or this axis, can also be created with a component, which we see here, this Cadwork axis. I just passed here these vectors, but of course change them. For example, if I put here this one, then also my my component changes. As you can see here now, like the N type is now rotated. Then we can also pass multiple attributes to the element in Cadwork. That means like name, grouping, subgrouping, and further user attributes. You can really add a lot of them. Then you can also add standard attributes like material, element color, IFC types, and more. And yeah, what I'm also was talking in the beginning, like these end types, they can also be added by a name. Here, just pass this name, which I have in my file. Now, for a second example, I want to show you this curved wall. This example was created by Ursula Frick from Blumer Lehmann. She handed that over to us for testings. And we see here that we can create with the combination of Grasshopper or Rhino, Grasshopper and Cadwork very interesting shapes or elements. Like here we have this curved wall, and we can now switch like some parameters from here. For example, we can change the height of that wall, and it also directly changes in Cadwork. Like now we have here this wall, which is changed in the height. Then we have also like the ability to create connector axis. We see here like this drilling. And if I just change the name of this connector, then it creates me like the new connector I passed to it. On the other hand, we are also possible to just create like a simple drilling, which is an axis with a diameter. And also what I was showing you at the beginning, like with the end type, when we switch here, like the name of the end type to the start of the element, then I also have here now like this changed end type. So, okay. Yeah, that was it now from my side with that short introduction to Cadwork and Rhino.Inside Cadwork. And now I will pass over to Miro, who will show together with Matias the use of Rhino and Cadwork of the project at the university. Miro will show mostly the use of Rhino, and then Matias deeps then into Cadwork and Rhino.
Okay, thanks, Michael. Then I can take over from here. I try to share my screen. Can you hear me? Can you see it?
Yes.
Okay. Yeah, welcome from my side for the project example, Rhino.Inside Cadwork. The project example, the design part in Rhino. As Michael said, I will mainly in my part focus on the Rhino side. Maybe I will also address people which might not know Rhino so well that you mainly can see the potential of Rhino, where it makes sense to use the software, and then I will pass over to Matias, who will go a bit deeper to the Rhino.Inside Cadwork part, which builds up on my part, how we used it in this project. Okay. Just super quickly to my side, how I end up to be here in this webinar. I've done an apprentice and worked in a carpentry in Bern, Switzerland. After that, I've done a bachelor in architecture at the PFH, where I'm now working again. But then I've done the bachelor in Bordo ARQ, Switzerland. I've done a master in architecture, the ITech master in the University of Stuttgart, which mainly focuses on digital design and construction. And since 2020, I'm working again at the PFH, but this time in Biel, focusing on digital fabrication and wood construction projects. And basically, over all this time, I have tried to put my focus really on parametric design and construction workflows with Rhino 3D and Grasshopper. And I think this is kind of the reason that I'm now ending up here in this webinar. Yeah, a project example project. Last spring, we have built this small, complex, triangulated wood construction or campus in Biel. It was basically a 1.5-week workshop, which we have done with 25 students. And how did it came to that? We had a request of an artist group who planned to build a huge heart for the Burning Man Festival in Nevada in the United States. And this is basically the geometry and the rendering which they handed over to us. And as you can see, this heart consists of a lot of triangles, and they are very tight sometimes. The tips of the triangles are very tight, and from a fabricational perspective, this is basically a nightmare. So we had to find kind of a way to abstract this heart, and there Rhino kicks in. So just to say it in advance, we have developed a workflow to rebuild this heart, but whenever you now see the full heart, this is not a final design, because we basically were just able to build in this special week with the students a small part of the heart. And the full heart is basically more, if you see the image, kind of a proof of the workflow, that we could use the workflow for the full heart to design an abstracted full heart, but we accidentally never had time to really do that and focused on a smaller part, on this small prototype, on the entrance part, which we then finally could build. We have done this together with the Balterschwiler wood construction company. We were able to cut out these triangular plates and then assemble it in front of our campus. But back to why Rhino 3D, why Cadwork, and why did we hook them up in the scope of our project? This is my personal opinion, why Cadwork. I think Cadwork really makes sense for 90% of today's wood constructions. Why Rhino? Let's say it's good for the rest 10%. Let's say for freeform wood constructions. By combining both, I would say it makes sense to play the strong part of each of them in one game. Rhino for geometry generation and Cadwork to fabricate the streamed geometry, to automatically create a nesting, the CNC machine readable ETL file, and so on. I really think it makes sense to not always reinvent the wheel from scratch. For sure, it would be possible to do all the steps as well in Rhino and Grasshopper. But if there is a specified software which can handle these fabricational steps, then it really makes sense to use them. So back to Rhino. As said, we got this geometry, 1086 triangles. It's really a lot, needs a lot of time to fabricate them. And as said, the angles are very very tight, the angles, which leads to problems by geometry generation as well as in the fabrication. It's not so optimal. If you use the default method by Rhino to reduce the polygon count, you can give it a try, but you will end up with something like this. And I think we all agree this is not the way to go for an artist-related project. So I've basically decided to build a Rhino and Grasshopper file from scratch, which is capable of doing a new heart design to end up with as regular triangles as possible, which are basically fabricable. It was in the end quite a huge Grasshopper file. I have to say it's not so common to do that huge Grasshopper files, but I basically did that as well for my students, which are not so experienced in Rhino and Grasshopper. And I tried to kind of create a workflow where they can step in and give it a try on their own. So I also kind of divided and separated the Grasshopper file into multiple steps, which basically make it possible to end up with such a hard or prototype geometry. So I will now guide you quickly through these steps, and then I will afterwards show it as well live, real time in Rhino. So I have decided to rebuild this heart with preps, with curves, with subtlees, basically with NURB geometry, which it's basically very handy to do a design with these geometry formats. Then multiple steps follow to create triangles and basically to make them regular and to optimize them in terms of geometry generation and fabrication. Quite an important step is the kangaroo relaxation. Kangaroo was a plugin for Grasshopper. Now it's integrated by default. And basically it's possible with this step to do so-called dynamic relaxation, to basically add forces to all the geometrical members, to the edge, to the triangles, to let them find an equilibrium, to let them get more regular for a more fabricable output. I have as well in the file implemented kind of a structural analysis. It has not to be understood as kind of a final go or no-go analysis, but I think it's very handy to have kind of a structural instant feedback in the design process, which enables you to see weak spots of the design. You can see in cantilevering areas, for sure, there are more tensions and compressions. And then when the design is still fluid in this design process, you can make changes quickly based on this instant feedback. More geometry optimization. In the end, I use my own Grasshopper plugin, which I've written to make, I call it a planar offset of the geometry, basically adding material thickness by creating all the sides planar, which is very good because of then in the fabrication process, we can use a circular saw as tool, and the plugin also handles the very complex node situation, which occurs in this complex geometry. For the end, we have to somehow connect the plates. Here, big credits to Design to Production. We have basically taken their idea of adding eine Gradleiste, I call it in German. It's basically a beam in between of the plates, which enables to add screws in a convenient angle and also in a stable angle, so kind of a connection element. So with this fully parametric workflow, we were able to create parametrically all the geometry which was necessary for fabrication. As well, there was the idea to make with this hard kind of a light show to electrify it. Here you can see all the outcuts for electric wires. And you can see we can quickly end up in this software with the quite complex geometry. So some detail views. And now I will just give you a super quick overview how this looks directly in the Rhino file. And I'm aware of this will be super quick. I can never ever explain everything, but just that you have kind of insight how it can look and that you can see the potential of basically using Rhino. As said, the Grasshopper file is quite huge, but in the middle I have created basically for easier usage kind of a control center, which now allows me to guide you again through these steps. As said, it's based basically on NURB geometry. If I make visible the according layer, you can see this NURB geometry, also sub-D geometry, basically has control points, and you can imagine it's quite easy to play around with them, to drag them around, to adjust the design. Then as said, multiple steps follow to create these triangles. Firstly, it has to be merged together, all this geometry. I've also implemented kind of a measurement to be aware of the size of the structure. Then meshing by the default component of Grasshopper to mesh such a structure, the three-mesh component. The output is quite nice, but I would say not nice enough. We still have very small triangles. We have some very tight triangles. Then as said, multiple steps to improve this situation. We also have always to be aware about the normal direction of the triangle, about the direction of the triangle itself. This is later it's important that later the material thickness, the offset happens in the correct direction. And you can see with every step, it gets more and more doable, fabricable, regular. My favorite step, the kangaroo relaxation. Now I'm using an engine, a solver, which outputs the geometry directly. This calculates a bit quicker, but it's quite fun to also see it in the dynamic way. So I quickly switch to another solver, turn it on and reset it. And now you can basically see the equilibrium process. The forces to the geometry are added, and the geometry tries to find a state where the triangles are as regular as possible. To go on, I will go to the zombie solver, it's called, which just directly outputs the geometry and basically makes the file fast and quick. So the next step, the structural analysis, the Caramba plugin, takes a few seconds to calculate. You can now see here, okay, when it's cantilevering, it's drawn a little bit more red. So in these areas, you have to think about if it's a good idea to do it like that. So already the second last step with my own plugin to basically offset the geometry. I will now not calculate the full heart because it takes around 20 seconds and just show you a part. You can see we have a material thickness, and if we zoom in a little bit in the extreme parts, you can also see that the node outcut is created individually and quite dynamically. If we have tight angles between the triangles, also the node is adjusted. And this basically allows to also handle very complex geometries. The last part is adding the Gradleiste, the beam which connects the triangles. Also this has some seconds to calculate. And yeah, basically this is the whole workflow on which then Matias built up to stream it to Cadwork and solve all fabrication issues. You can now see the Gradleiste geometry, and for sure also the outcut of that. One moment. Yeah, basically after this step, multiple steps would follow to include the outcuts for the electricity, but it just explodes the time we have. I just show it till here. This part outputs the closed B-reds. This is the geometry format which we like to have for fabrication. And with this, I will hand over to Matias, who will show how we went on to stream that to Cadwork.
Okay. Thank you, Miro, for nice explanation of the file. I will share my screen now. Okay, should be fine. You seeing it? I think so. So, also a short introduction about myself. I did architecture in Chile at the Pontificia Universidad Católica de Valparaíso. I founded a small company, Bordo Architecture, so architecture and construction studio, where I was working until 2018 when I came to Switzerland to do this master in wood technology with the specialization of complex timber structures at the BFH. Since 2019, I'm working at the BFH, same as Miro, as an assistant and a research assistant in digital construction and beam research project. So to start with, how do you get from a 3D model to the end product? Luckily, the two of them look really almost the same. They are like at the millimeter, like really accurate geometry. So, but how do you get from one to another? What are the things that we need to take care into consideration before manufacturing? And how does this interface between Rhino, Grasshopper help us, and Cadwork help us to generate this geometry in the most accurate way? So first, we start with the geometric analysis. What do we have in our models? What are the elements that are being streamed natively in Cadwork? As Miro explained, we have like the beams and plates with proper material definition and really accurate geometry. I will show it afterwards in a live demo. What are the stream geometry and what are the relevant aspects that we need to take care into consideration. Second part would be the manufacturing operations. Okay, do we have a correct position and type of the connectors? What are my drilling axes, as Michael explained? What are my hard soft operations between the components? Can I get how do I place my dowels there? Do I place them on the beams? Do I place them on the plates? Also, that's really relevant is to have the time and raw material estimation based on this data. So it's the added value also is that we not only have like empty geometry volumes, so we do have like components that they know what they are. So they are actual materials. It's not just about rendering the surfaces of them. It's like really giving them attributes and material properties. So in this picture, you can see on one side what we see as humans and what do the machine more or less seeing. So we have the lines, you see there the cutouts, you see the drilling aspect. So we really need to take care about accuracy of geometry, tolerances for machining. So if I'm drilling that, do I need an additional tolerance or another diameter for drilling it? As I've said, the material geometries, material properties, sorry, machining operations that I want to perform. I have to know what machines I'm going to use for this, and also for the assembly aspect. So what are my assembly groups? How do I organize my construction site? Because prefabrication is one step, and if done properly, you can assemble this just in a couple of hours. Nowadays, you can assemble a whole house in one day if you want, if done properly. So organization and planning is really important. Also the shop drawing, so for the humans to assemble it. Here in this slide, you can see in the bottom right corner the machine we use from Rapperswil. And then you also see on the other two pictures, okay, the amount of operations that we were like putting into our components. So making the contouring pockets, the drilling operations, and the cutouts, the hip valley cut, you see. So there are many operations that you could do, and it's good to analyze them before you ship them into machine. So once you are in the machine, you cannot change everything. So it's better to do them before, and imagine doing that in thousands of components. If you can avoid one step in this, so one machining operation, you could save a lot of time on the warehouse, on the construction. Another aspect that that help us with this live interface was to have a data-driven assembly planning process, so we could easily estimate the weight calculations based on the materials we were choosing, the assembly and disassembly process, and the fitting of special components. We did this, the mock-up where the one-to-one were assembled on our workshop at the BFH, but if this would have been transported in trucks, we would have to cover the corners, not to damage them. We did some mock-ups based on the models that we created. So it's really a stream of live geometry that help us to plan and to understand better our structures. Once we get the objects, the plates, we do the nesting. So we assign them a manufacturing, a position number. Also for the plates, imagine them, they all look more or less the same. The machine doesn't care if there's like 1,000 of only 10 plates, they will just cut it. So we assign a certain number of them. Also for the individual beams. And this enabled us an automation of production data. So we have production numbers, assembly groups and subgroups, as I said, and to save material also. So we can nest them all in one plate maybe. We could save time, we could save raw material in the whole process as well. So this is the manufacturing process. You could see the triangles are really nicely done with the edges and everything by the machine. So that was done accurately. In the next video, I will show more or less, so for you to have an overview of what's the machine doing. So you can have, like in this CNC, you change the tooling of the machine. So then you can mill, you can cut. So just to have, for you to have an understanding of what is happening inside the machine. And again, how can you more or less save time if done properly? Again, the final product. So we have the Rhino file, the Cadwork import geometry, and then the real one. You may see this little notch there is not on the physical model. Well, this was assembled by students. They forgot to just cut that out. So the human factor is always there, but in this case was not so terrible. Everything fit up to the millimeters. So you see everything is tight, nicely done. The position of the screws were perfect. So everything fit. Now I will shortly show you the live demo to how do we check the imported geometry and how do we prepare the production data. So let me show you this now. I get this. So this is more or less the Rhino file, the Grasshopper element. You see, This is the geometry done properly. And this is the stream geometry in Cadwork live. So if I just slightly stop to share that, and I go to my curve, I could more or less select it and enable the control point of it. That is not being done. Now they have. Okay, so I will just do a slight change on the geometries for you to see how it reacts. So move it back. The whole thing regenerates, recalculates, and if the file is robust enough, it should give me the proper geometry. So then you see the bench, the axis system, then everything is being regenerated, and the corner over there has been changed. So yes, we did it properly. I go back, Control Z. That was one step to see the robustness of our parametric script. It will recalculate again. Great, I think I'm still on time. I will block this. So then again, about the plates that we have in here, you can see there's a name, material name. I'm at the group, and a subgroup. I have a real width, thickness, the position of the weight and everything. And I could do this once I've checked that my geometry is fitting properly. I could change my material, so you can also regenerate that and rechange it, do it again. So if you were to say, okay, let's do it in another material because the weight is too much, you can do it automatically. Another aspect that is really important for this workflow is that we also get accurate thickness. So if I'm working with OSP, I will go to change maybe to my OSP thicknesses, and I could change my material thickness. So the thickness of the plates is being done in Grasshopper. I'm assigning them a material type and my standard material thicknesses. So yeah, it recalculates. Now there you can see, okay, then the plates are too thin to being produced. So I go back again to my Kerto plates, and I will go to my original material thickness, Kerto 451. That's perfect. This will take a while since the plate was a bit thicker. So there you have it. All right. Another aspect I wanted to show you now is about the beam aspect. So semantic data is quite important nowadays. So you can assign the correct IFC type, IFC plate. You can assign also the assembly groups and the materials. So here I have the assembly groups 1, 2, 2, 1, and 2, 2. And if you can see this here in Cadwork, another aspect is to check the reference panel and surface for the nesting aspect. So these red surfaces mean that this is the reference panel. This will be on top, so the machine will do the operation on this side. Here you may see that there's a couple of them that are wrong. So if I were to check this, I would take this to Cadwork, the group. I will move it, and I will easily just change it. So then that's the perpendicular axis of this, and that I don't need to do any other step to bring this into the nesting part. So that's also quite powerful to do. And the final part I wanted to show you now. Okay. It's about the drilling axis. So this is quite tedious to do manually, one by one, especially if you don't know where they will be finally positioned by the structural engineer. And so this is really important to see, okay, what is my diameter? I can change this to 6 millimeters. And before you send this to the machine, okay, what if the machine is drilling this up to 6 millimeters and then timber shrink as well? you won't be able to put them over there if there will be two dowels. So one aspect that you can add here is the tolerance. So you can control this parametrically. That being said, here you have it. So diameter is 6 and the drilling tolerance is 3.9. So that is really powerful data that we put into our models to ensure that manufacturing and production is done accurately. Looking at the time, I think that this will be everything that I will show you now. This interface, as Miro said, we could talk for hours about this. And yeah, but for now, I think that's more or less enough. And just to finish it, so then you can see the whole workflow, which is a fully interconnected and parametric workflow we did from the model towards integrating the geometry, position of the drilling axis, evaluation of everything, doing the nesting, and assembling it properly. So that's for my side. Guys, thank you very much for your attention. I hope we still have some time for Q&A. Carlos, you said us.
Yes, sure. So many thanks. It was excellent presentation, great variety of projects, very detailed segmentation of each part of the workflow. Some people, one guy mentioned that where was it? Yeah, loving the rigorous parametric process, because it was very, very nice explained for these student projects and all the rest of the projects, also seeing the machine in action. So wonderful. Also greetings from, again, I'm from Valtech because you named them, okay, as one of your partners. Also, well, I know Bloomer Lehmann and Ursula Frick. And yeah, some people are asking if it's possible to share some of the initial Grasshopper definitions or maybe some of the models. I don't know if these are private or you can maybe share, or I know in your website there is documentation and there are some examples, but maybe you could put there a more, I don't know, share the Grasshopper definitions you showed today.
Yeah, I would basically have to ask directly at the university how we handle the situation. But for now, just contact me directly over my website, over the BFH. And I mean, especially interesting it's if there is a project, and then we can find solutions. I think it's the idea that this stuff is used. But so far you cannot download it, but feel free to contact. Or how do you?
No, it was amazing. I love the projects and the precision and well, there is one question actually. It's a bit controversial by Krauschik LS, and he or her says curious to know what advantage does Cadwork provide in this workflow? Why not completely model in Rhino?
Yeah, I can try to answer this again. I mean, it would be possible, but if it's possible on the click of a button, I also refer to earlier projects of me where I created beams for a structure, and in the end, the process was just imported to Cadwork, push one button, and then you have the BTL file. For sure, you could code the CNC file directly line by line somehow in Grasshopper or by adding Python or C#, but if there is a software where many people invested a lot of time to solve these problems, it basically just makes sense to use this software.
No, I see. It would
it's
be like
also just in the workflow of the project itself. If Matias is able to handle Cadwork, it also takes work from me, so I have not to do every step, and I can give some steps to other people who know how to do it in their software. So
exactly. Of course, you could program everything, but it's like programming again Cadwork.
Yeah, it's reinventing the wheel from scratch. I mean,
exactly.
It would be fun, but you need to have the time, and if there is a solution, and
I understand.
if somebody who can do it, then it's quite nice.
I just wanted to share the question so that you could explain the advantages of course, also, the benefits of using Cadwork.
Yeah, also about the material property. So you have a certain specific weight for each material density that you can you just add this semantic data in the program itself, which is really helpful in Cadwork. Then you can prepare the whole assembly process and the shipping also of the individual components based on that information.
Yeah, and also like the geometrical analysis you have in Cadwork, you can analyze them elements and get like the process for the machine. I guess if you do this in Rhino, I'm not sure if that's, or it would take a lot of time just to program that, because as you said, Carlos,
I mean,
you would have you would have to program everything
it yourself,
for sure,
optimize algorithms.
I mean, you could, for example, use the Woodpecker plugin. For sure, there are always different solutions, but now we had also the skill sets to do it this way, and it makes sense to use it.
It's clear. One more question, but I think you answered this already. If you are able to import and/or export BTL files from Rhino, from and to Rhino. So it's like the file for exchange file format. The ideal exchange file format is BTL. Well, with this, of course, you don't need any file format, no, because it's directly linked to Cadwork. But otherwise, does Rhino or Cadwork could also share information via BTL?
Yeah, I don't know if I got it right, but for the we are doing it with the native with 3DM format. The exchange, we have a 3DM import and export. Yeah, that's the way how we share or exchange this data. We have also like a plugin for Rhino, Cadwork tools, and you can use this without the Grasshopper, and you can like define all attributes and like all these axes in Rhino and then bring the data to Cadwork.
Okay, so no need for BTL. What else? Yes, another question by Charles Thierry de Ville-d'Abreuil. Long name, but I know the guy, very nice guy. Hi, Charles. Can Rhino circular section holes be detected and automatically transform into Cadwork drill axis?
You could in Cadwork, like if you bring geometry with holes in it into Cadwork, then Cadwork has like an algorithm which detects then this radius and generates directly a bolt. This is also like very powerful when you bring data or geometry from or external geometry, then you can like generate them drillings with this algorithm.
Great. So it recognizes geometric properties from other softwares, no, or from any 3D model. Nice.
Yeah, it analyzes the geometry.
Cool. What else? Yes, how the shop drawings have been drawn.
Well, yeah, in this case, once we generated the geometry and we imported into the Cadwork, we used just the command in Cadwork to generate the shop drawing. So it was taking all the plates as Cadwork calculated, which is a really good tool, and then it generates the 2D drawings out of it, even with perspective and axonometrics. So everything that you set up in your init file in Cadwork will take the geometry you imported and will generate the shop drawings out of it. So then just one step procedure. Yeah.
Perfect. And yeah, well, it's pretty the same question. If the shop drawings are completed in Rhino or in Cadwork? And Cadwork, you said,
Cadwork.
right? Because there are also more attributes and properties of the materials as well. And
yeah. I think this is the breaking point for architects, maybe, that they're doing these highly detailed 2D drawings in by hand. Automate them, let them automate. Cadwork is really powerful in doing that.
Then we have some spammers here, and then I think it might be one of your colleagues or an expert user, Daniel Depoe. He says, You can use the Cadwork API to auto-generate the 2D shops, but this doesn't involve Rhino.
Yeah,
So
yeah,
you
this
also have
like
an API.
yeah, this like the thing I taught like with the Python API or C++. Both of them are very powerful as well.
Mm-hmm. Also, greetings from Sylvain Usai from Design to Production. I'm sure you have worked together, no, in many projects. And one question from him: nesting picture. Actually, that's great. Also, that you have nesting incorporated in the product. He says that nesting picture shows the detailed volumes on a plate, but I assume you also need to consider the full operation, including entry and exit of the tool in the plate. How was this done?
This was done mainly by doing the nesting, optimizing it on the plate, and then we send the nesting file to Rapperswil for them to kind of validate it before putting it into the machine. That was the workflow we did.
Nice. So that's a CAM add-on or a
normally
analysis?
they then import it into a CAM system, and then they can demonstrate the processes.
Yeah, like in your slide, Michael, with the LignoCAM. So then you see the whole tooling operations and you can move them around.
I think LignoCAM develop or design to production a BTL importer, or if I'm not wrong, or something to work with those files. Well, now I'm not sure, but it should be on food4Rhino as well.
Yeah, there's a plugin like the Woodpecker and also like a Rhino plugin from design to production.
Nice. Some more questions. This one by Adriana Mogosano. Is it possible to write assign attribute data to elements in Grasshopper? Data would be from Excel.
It's basically easily possible to read the Excel file into Grasshopper, and then there are also plugins where you can assign it to the geometry, and I think especially in Rhino.Inside Cadwork as well.
Yeah, so anything that Grasshopper can handle, it's later available in this solution.
Yes.
Thank you for the great presentation from Andy Kilduff. And Matias Penrroz asks if the Rhino Common Library is accessible from inside Cadwork. I don't understand the question very much. I mean, Rhino Common is available through Grasshopper. I mean, but well, I don't know if you understand the question. I mean,
yeah, maybe it means like
if your
Python,
or if your link is open source, I guess. I don't know. Or if you had an API for Rhino.Inside Cadwork.
Yeah, that at the moment it's not open source, and there's also not an API on that. But as I may know, you can use like with this Grasshopper component for the Python in Grasshopper. Mm-hmm. There you have access to like the public components like Beam or something like that. And I did not test it, but probably you can also like script the requested parameters for the
so you could edit these components, your own components.
Yeah, but yeah, never tried it.
And well, the last questions, this one from Sam Tusky. A quick question about this process. Does this work for both additive and subtractive manufacturing? Will the shop drawings be part by part or as an assembly, or is it up to the designer?
Well, I think that we did like a subtractive geometry where we were milling out the timber of the plates. Additive manufacturing, I'm not sure if I understood it properly. In which regard or which extent do you think this would be an additive? Because usually in timber you take out material, you mill out, and once you generate the geometry, you think about how to to manufacture it, to produce it actually. And
So-
most of the machines are like taking material out. And then the second one about the shop drawings. The shop drawings, you can configure them. That's why it's so relevant to get the groups and subgroups. So with subgroups, you can pick a whole group of components and generate the shop drawings out of them. So that's a powerful, the power of grouping data so adequately in the whole workflow.
So you see
being
how to
organized.
do the assemblies, right?
Yes, yeah. So being like a good planning will result in a good execution process.
Thanks. And the very last question. Well, in the middle of these questions, there are many people. Thank you for the great presentation. And yeah, which tolerance settings are used in Rhino Grasshopper? Do you to the millimeter, to the 0.1 millimeter, or?
Yeah, the file is basically in millimeters. The actual Rhino tolerance I don't have in mind. It's 0.001, I don't know.
Yeah, no, I would, if you use it, you have to set the Rhino tolerance very high, like in millimeter, but then like 0.7 or 0.6.
It doesn't make sense to use a tolerance higher than the machine.
Yeah, exactly.
Okay. The last question. I think I might have missed this in the presentation, but can you program cut tolerances into members to accommodate internal hardware to avoid collisions?
It's not been done now, but for sure it would be possible.
Cut tolerances to members to accommodate internal hardware. Okay. Yeah, I guess an example would help you, right? For this question. No?
Yeah.
I mean, you have, if you visit the food4Rhino, the Rhino.Inside Cadwork food4Rhino page, you have there the contact details of the team of programmers and product managers. Feel free to contact them directly for any additional questions. And yeah, many thanks for this great presentation, and especially not only for showing the solution, but also for showing the workflow, which is both things are as important. And please continue adding new things to this live connection, because at least all the people that watch this webinar love it. And see you maybe again in a couple of months, whenever you have new case studies or new examples or new additions. We'll be glad to organize one new webinar. So many thanks. Have a nice evening. And to the audience, the same. Many thanks for watching our webinars, and see you soon. And remember that this has been recorded. So if you missed any part of the webinar, just refresh this link, and you will be able to watch it since the beginning. So thank you, everyone, and have a nice evening, day, or morning.
Thank you also, Carlos.
Thanks a lot.
Thanks, guys.
Thank you very
Bye.
much.
Have a nice evening. Bye-bye.
Bye.
Bye.